Today we'll discuss about the basic concepts of unit hydrograph. It is a part of hydrology for beginners. Under the hydrology for beginners, we are now, for the last few weeks, we are doing a lecture on hydrograph. So this is the part 4. In the previous classes, I have discussed about base flow separation, then we have solved some problems related to base flow, ERH, excess rainfall hydrograph, DRH, direct runoff hydrograph, etc. So today we'll go with the unit hydrograph. So what is unit hydrograph, why it is important, how it is applied, this such type of questions I will try to answer. So unit hydrograph can be defined as a direct runoff hydrograph or DRH of 1 unit of excess rainfall occurring uniformly and at a uniform rate over a catchment for d-hour duration. So basically unit hydrograph is a 1 unit amount of excess rainfall has taken place in a catchment, and what will be the direct runoff hydrograph for that unit of excess rainfall. As you know, direct runoff hydrograph or excess rainfall occurs when all the initial loss and infiltration losses are deducted. Okay, so ER is actually the actual rainfall minus initial losses. ER is the actual rainfall minus losses or initial losses, to be more precise. Okay, so suppose there is a 1 centimeter excess rainfall ER, then what would be the resultant direct runoff hydrograph? Here also direct runoff means runoff, total runoff or actual runoff minus initial losses. Okay, so that is what they are trying to represent with the help of unit hydrograph. The benefit of using unit hydrograph is when there are complex storms that occurred in the watershed, then the method of superimposition can be done easily. And there are two more very important assumptions due to which the calculation of the impact of excess rainfall on a catchment or on a hydrograph can be easily established. But remember that this unit hydrograph has a huge assumption errors. That means due to these assumptions, there are lots of error in the representation of unit hydrograph. That is why they say that it is a lumped response to the catchment or from the catchment to an unit rainfall excess. Okay, so check the second point. It represents the lumped response of the catchment to an unit rainfall excess, not a distributed response. And also volume of water contained into 1 unit hydrograph is equal to rainfall excess. So that is a known fact, because in the earlier presentation also we have said that if you multiply catchment area with the area of excess rainfall hydrograph, then you will get the volume of water stored in the direct runoff hydrograph. So that is established fact, so I will not go into it. So here I also said that if you want to know the water volume for this unit rainfall, you can just multiply the unit rainfall with the catchment area and you get the water volume of that watershed. And it is also assumed that rainfall generating unit hydrograph is considered to have an average intensity of 1 by d centimeter per hour for a d-hour duration storm. Now, this is very important, this duration of storm. When we say that there is a storm of 6-hour duration or 12-hour duration, or say for example 3-hour duration, or in the notation, standard notation form d-hour duration, then for a unit hydrograph, you can consider that the average intensity of rainfall will be 1 by d centimeter per hour. 1 centimeter is the excess rainfall that has taken place uniformly, as we have already assumed, for d-hour duration. So 1 by d will be the rainfall intensity for a hydrograph of, or for a hydrograph which has been generated due to the 1 centimeter excess rainfall. And this hydrograph is also a direct runoff hydrograph. Please note that in case of unit hydrograph, we do not consider any loss, both in case of rainfall or in case of runoff. We straight away deduct the losses and we consider only the relationship between the excess rainfall and direct runoff. Right? We do not consider any losses. Okay? So mind it. Okay, so what are the things that you must remember while doing or while trying to solve numerical problems under this topic, unit hydrograph? First thing is that this 1 unit of unit hydrograph is generated due to 1 unit of excess rainfall for d-hour duration of what? This duration is not for the hydrograph. This duration is for the excess rainfall. This is a very important aspect you must remember always. Whenever you are seeing this d-hour duration, it is not for the hydrograph. It is for the excess rainfall. How much duration of excess rainfall has occurred? Because after the excess rainfall has taken place, then only direct runoff will start. Because we are already deducting, or we are not considering any losses here. So when a 1 centimeter excess rainfall occurs, that means this 1 centimeter is over and above the losses of rainfall after the rainfall has started. So just recapitulate that when a rainfall occurs, parts of that rainfall is infiltrated out, parts of it goes above, evapotranspiration, infiltration, some part of is captured by the forestry of that area, and some part of it is captured also in the depressions of the catchment. So we are deducting or ignoring all these losses of the rainfall, and whatever is above that losses, suppose if there is a rainfall of 1.5 centimeter, then and 0.5 centimeter is a loss, so we are not considering this 0.5 centimeter, we are considering only this 1 centimeter. Okay, so always try to differentiate between excess rainfall and actual rainfall or total rainfall. Total rainfall is actually actual rainfall plus losses, but excess rainfall is actual rainfall minus losses. So always remember ER means over and above the losses of rainfall. DRH, direct runoff hydrograph, is over and above the losses of discharge. When after rainfall, the parts of water goes inside the ground, parts of water get evaporated, parts of water get entrapped, and then after satisfying or saturating these things, discharge start or runoff starts. So we are talking about those runoff only. We are not talking about runoff plus loss. We are talking about only runoff. So that is why what we say, total runoff minus base flow, that is your direct runoff. And when you plot that direct runoff in a 2D curve, you get the direct runoff hydrograph. When you plot the excess rainfall with respect to time, you get the excess rainfall hydrograph. Okay, so in case of unit hydrograph also, we are only concerned about excess rainfall and direct runoff. We are not concerned about losses. So just ignore the losses term and then try to visualize. So here also, when we are talking about 3-hour duration, 6-hour duration, 12-hour duration, D-hour duration, that means the duration of the excess rainfall, not duration of the runoff. It is the duration of excess rainfall. So this is often confused by students. They think this duration is about the runoff. No, it is the duration of the excess rainfall. Okay, and that so what happens to the definition of unit hydrograph? So 1 unit of excess rainfall is occurring uniformly over the catchment at a uniform rate also for a d-hour duration, that is for the excess rainfall. D-hour duration, for d-hour 1 unit of excess rainfall has taken place uniformly and at a uniform rate all over the catchment. Then the direct runoff hydrograph that can be generated from that excess rainfall, we defined it as unit hydrograph. Is it clear? Okay. So the runoff or the hydrograph generated due to a d-hour duration 1 unit excess rainfall is known as unit hydrograph. There is no confusion in it. Okay. So this is one thing, and yes, as we have earlier said, this is a lumped response because we are considering only unit hydrograph. So this is a lumped response of the catchment, not the distributive rainfall, distributive response. Because first thing is that in actual cases, rainfall cannot take place uniformly over a watershed. In some part of the watershed, there will be excess, there will be more rainfall compared to some other part. Okay, and the rate is also varies throughout the watershed. Okay, so this is also a very large assumption. That is why they say it is a lumped response. And of course, this we already know that ER into catchment area is DR. Matlab excess rainfall into catchment area is your direct runoff, volume of direct runoff. So that is why volume of water contained into unit hydrograph is equal to rainfall excess. Hence, water volume is equals to 1 centimeter into catchment area. It's very easy. And yes, this is another definition. You can say that d-hour duration of 1 centimeter rainfall, excess rainfall taking place. So I can easily say that average intensity of the excess rainfall will be 1 by d, centimeter 1. This centimeter is for the rainfall, and this hour is for the duration of the rainfall. Always remember, this is duration of excess rainfall, not your hydrograph, not your runoff. In case of unit hydrograph, we also assume two very important aspects. What are they? They are time invariance and linear response. So Time invariance is should be linear response. Look, what is this assumption implies? The assumption implies DRH, direct runoff hydrograph for a given excess rainfall ER in a catchment is always the same irrespective of when it occurs. So whether it is happening in summer or winter, whether it is happening in a day or night, DRH, the response to that unit ER, is always the same. So this is one very important assumption. Okay, so time invariance. Okay, because in case of summer, you see the catchment or watershed is very dry. So the response is different compared to from a watershed in a monsoon. Because in case of monsoon, there is water in the catchment. So often the watershed is saturated with water. So the response is different for a rainfall in summer and monsoon and yes, in winter also. Okay, in rainfall of summer, most of the water get absorbed by the watershed because of the dry intercellular pores regions. They want water because there is no water in the intercellular regions of the soil pores. So they want water due to equilibrium and they absorb water. But in case of monsoon, already there are many rainfalls, so they are already saturated or semi-saturated. So when again a rainfall takes place, then a less amount of water is absorbed compared to summer and winter. In case of winter, situation is better than summer, but yes, still the response is different. But in case of unit hydrograph, what we assume is that whenever there is an excess rainfall of 1 unit, 1 centimeter, the responsive DRH will be same. Okay, so this is for easiness of the calculation. You know, in case of Ohm's law or this famous Newton's law, there is lots of assumption. In case of Ohm's law, this Ohm's law is valid. Ohm's law means voltage is proportional to current, so V is equal to I into R. I is current, R is resistance. But this is valid only if you are measuring it within a chamber or within a region where the temperature is maintained equals to or below 20 degrees centigrade. So there are many other assumptions for Ohm's law. Same for this our P is equal to mf from Newton's first and second law of motion. P is equal to mf doesn't stand if there is friction. Only if there is no friction this will stand. So there are assumptions. Without assumption the governing laws will not stand. You cannot fix or you cannot conclude any governing law because hundreds and hundreds factors contribute to the relationship between pressure and acceleration or between voltage and current or this rainfall and runoff. So you have to take assumption. So here also time invariance, one, always response is same whenever it occurs, rainfall occurs. Another one very interesting assumption is linear response. The response of the watershed to a ER is always linear for unit hydrograph. So what that means? That means if there is X amount of rainfall, X1 amount of rainfall, then Y amount of runoff will be there. If there is X2 amount of rainfall after that, then Y2 amount of runoff will be there. And then we can say that if it is a linear, then we can say X1 plus X2 rainfall will give a runoff of Y1 plus Y2. But actually in actual case it is not the case, as you can easily say that after one rainfall the catchment is rather saturated, so Y2 will be different. Okay, so for x1 y1 can be generated, for x2 y2 can be generated, but for x1 plus x2 y1 plus y2 may or may not be generated because of hundreds of other factors contributing. But when you say that this is linear, yes, then it is possible. X1 plus x2 will generate y1 plus y2. Again, you can say this, that any factor r into x1 is y1. Yes, you can say that also. Okay, if you multiply r with x1, then it will come y1. Straight away you can say. Or if you say any integer r, I multiply with the ordinate of er, then it will give dr. So this type of linearity can be possible. If I say that linear response is there between dr and er. Here dr is direct runoff, er is excess rainfall. So let us solve two problems. First problem, numerical problem 1. Ordinates of 6-hour unit hydrograph is given below. If this is the interesting part. Time you see in hours 0, 3, 6, 9, 12, 15, 18, 24, 30. Then you will say, this is not 6 hours, this is 3 hours. And also it is for a 30-hour runoff. Then why you are saying this is 6 hours? So as I earlier said, this 6 hours is for the duration of excess rainfall, not for your hydrograph, not for your runoff. Okay. Now the question is like that. Ordinates of 6-hour unit hydrograph is given in this table. This ordinate is for the unit hydrograph. That means 1 centimeter rainfall has taken place for 6-hour duration, and then this hydrograph has been generated. This direct runoff hydrograph has been generated. Clear? So 1 centimeter rainfall, 6-hour duration for this 1 centimeter excess rainfall, and the generation or impact of this is this unit UH ordinates. Okay, 0 to 25 and all this thing, cubic meter per second. Okay, so this is the result, this is the cause. Right. This is the cause, this is the effect. You can also say that. So what you have to find? You have to find, calculate the ordinates of the DRH, direct runoff hydrograph, due to rainfall excess of 3.5 centimeter occurring in 6 hours. Correct? So here you see it is linear response. They are saying 1 centimeter response is given. This unit hydrograph ordinate is for 1 centimeter excess rainfall for 6-hour duration. Now we have to find out 3.5 centimeter excess rainfall for the same duration. What will be the ordinates of runoff? It's very easy. Just multiply 3.5 into the ordinate of DRH. 3.5 into DRH will give you the ordinate of ordinate of DRH for excess rainfall of 3.5 centimeters. So for an excess rainfall of 3.5 centimeter or 5 centimeter or 6 centimeter or 10, whatever will be the case, if it is R, let us say R is this 3.5 centimeter, straight away multiply this R with the ordinates of the unit hydrograph generated due to the 1 centimeter excess rainfall for 6-hour duration. Only thing that you must notice, whether this duration and your the duration that you want is same or not. That means here you see 3 point, they are saying calculate the ordinates of the DRH, okay, due to rainfall excess of 3.5 centimeter occurring in 6 hours. I have the data of 1 centimeter excess rainfall occurring in 6 hours because duration is 6 hours unit hydrograph. Then multiply straight away 3.5 with the ordinates of this. So 3.5 into 25, I think it is having nearly 87.5 and so on. Correct? So if I use the calculator, I will see that so if I use the calculator, what is coming? Just multiply 3.5 with the ordinates of unit hydrograph. Because we assume linear response for unit hydrograph. Only thing is that you see that whether the duration of this 1 centimeter of rainfall matches with the duration of this 3.5 centimeter rainfall. So here whenever I am talking about rainfall, it is actually excess rainfall. So if the 1 centimeter excess rainfall has the same duration as the 3.5 centimeter excess rainfall, just multiply 3.5 with the ordinates of the unit hydrograph generated due to the 1 centimeter excess rainfall of 6 hour duration. That is all you have to do. So it is as simple as that. Just multiply 3.5 with the ordinates of unit hydrograph generated due to the unit rainfall, 1 centimeter excess rainfall for 6 hour duration. So here it will be first one 0 into 3.5 is 0, but the second one will be 25 into 3.5, that is 87.5. That is correct. Next one is 50 into 3.5, that means these would be 175. Again, then 85 into 3.5, 297.5. Then 125 into 3.5, 437.5. Then 160 into 3.5, it is coming nearly 560, and so on. So this is the way, because of our assumption that linear response, this 1 centimeter here will always have a linear response of DRH, and as the duration of 1 centimeter excess rainfall and 3.5 centimeter excess rainfall 6 hours is same. So due to the linear response assumption, we can straight away multiply 3.5 with the ordinates of the existing unit hydrograph, and we will get the ordinates of the DRH due to the rainfall excess of 3.5 centimeter occurring in 6 hour duration. Remember, as I have said, this duration is for the rainfall excess, not for your hydrograph. Okay, another problem, numerical problem 2, another kind of problem. Ordinates of 6 hour unit hydrograph given in the table below, same data. And you have to calculate the ordinates of the DRH resulting due to two successive storms of 2 centimeter excess rainfall and 3 centimeter excess rainfall. However, both have a duration of 6 hours, but one coming after the other. Correct? So here there is something you have to do. So you will have to do you have to draw a table, and then what you will do is, in the first column I will show just 3 parts. For these 3 ordinates I will show. After then you have to do it for your practice. So in the first column write what I will write, the time. In the first column I will write the time. Second column I will write the unit hydrograph ordinates for 1 centimeter excess rainfall. And this time is how much? 0, 3, 6. Okay, let me do another one, 9. This time is in hour. Note that. And in unit hydrograph given is 0, 25, 50, 85. Now I have to find the ordinates of DRH for 2 centimeter and 3 centimeter excess rainfall, one happening after the other. Both have 6 hour duration. Okay, so due to this linear response thing, what I will do is for the first storm, 2 centimeter storm, first 2 centimeter storm has come, then after 6 hours, 3 centimeter storm has come. So what we'll do for the 2 centimeter storm, I will straight away multiply 2 with the ordinance of unit hydrograph. Correct? As you have seen in the problem 1. So 2 into 0, this is the 2 centimeter TRO, direct runoff ordinate for 2 centimeters. So 2 into 0, 0. 2 into 25, 50. 2 into 50, 100. 2 into 85, 170. And so on. How I can do this? Because this 2 centimeter rainfall, excess rainfall has occurred from 0. Okay. But this 3 centimeter excess rainfall has occurred after 6 hours of the first storm. So for that what I have to do is, here I have to lag this unit hydrograph by 6 hours. I have to lag this unit hydrograph by 6 hours. So what will happen? First hour 0 I will not do, 3 hour I will not do, 6 hour I will not do, or from the 6th hour I have to start. Okay, so 6 hour I will do. So first I will write 6 hour lagged hydrograph. So this will be our 0, this will be our 25, then this will be our 50, this will be our 85. Correct? So I'll leave first two row and then write the same unit hydrograph again. Okay, and after then I will multiply 3 with these values. So 3 into 0 will be 0, 3 into 25 will be 75, then what happens, 3 into 50 will be 150, 3 into 85 will be 3, 5, 15, 255. And this is successive storm. So the contribution of first storm will be added to the next storm. So what happens is, as you can see, you can see I have leave the first 2 row because of the 6 hour lagged start of the second storm. So from here, 100 is a 2 centimeter ordinate. So 100 plus 0 will be 100. And then 170 plus 75 will be 7, 7, 14, 1, 2, 245. Right? So you can understand 2 into 85 is 170 and I have 3 into 25 is 75, and then I am adding both this, so it will come at 245. Now if I consider this part also, this the ordinate of 12th hour, then I can add 150 with that and so on. Okay. So for these cases, when there is a delayed start of the second storm, then you have to lag your given unit hydrograph ordinates by 6 hours or by 12 hours, the lagging time, and then multiply with the excess rainfall of that lag storm. And if both are successive, there are 2 or 3 or 4 or 5 successive storms, then you will just add them one by one. So again I am repeating, in this problem too, this is something special. Ordinates of 6-hour unit hydrograph is given. Calculate the ordinates of the DRH resulting into two successive storms of 2 cm and 3 cm excess rainfall of 6-hour duration. So first storm happening at the same time, second storm 3 cm storm happening after 6 hours, because both the storm has 6-hour duration. So what happened is, for the first storm 2 cm, straight away multiply 2 cm with the ordinance of the given hydrograph, given unit hydrograph, and you will get it. The ordinate of the 2 cm direct runoff hydrograph. But for the 3 cm direct runoff hydrograph, what you have to do is you have to lag or leave 2 rows and then write that unit hydrograph again, and then you multiply 3 with the ordinance of that lagged unit hydrograph. So once you have done that, then you add with the corresponding ordinance of the 2 cm excess rainfall DRH. Because they are both are successive, so you have to add one with the other. So after doing this lagging and multiplying with the ordinate of the excess storm of the second one, you add corresponding ordinates only to find the resultant ordinate of the DRH for the second storm. So this is the solution to the numerical problem 2. If you have any confusion, you can comment. So with this, I will finish hydrograph part 4 tutorial. Thank you.